So folks, we're moving into section 17.6, and in this section our goal is to understand surface integrals. So the individual objectives are to understand how to give a parametric description of a surface, and that's what this pre-work will largely focus on. And then we will learn how to perform various surface integrals, and in this pre-work we'll focus specifically on the integral that finds surface area. So before we do that, let's actually just be a little bit more careful about what we mean by a surface, even though we've looked at them quite a bit in this class. So the first thing I want to say is that a curve, which we've studied, is a one-dimensional object which lives in either 2D or in some higher dimension. And because of this, we describe curves parametrically as something like r of t is equal to f of t, g of t, if we think of the curve as living in R2 for some a less than or equal to t less than or equal to b, or r of t is equal to, let's put it in R3, f of t, g of t, h of t for some increment of time. So the key thing to keep in mind here is what we're taking is a single variable, and our curve r is a map from R into R2 in this case, or over here, this curve R is a map from R into R3. So we will now look at a surface, and we're going to think of a surface as a 2D object living in either 3 dimensions or some higher dimension. And because of this, we will describe it parametrically, not in terms of just one term, but in terms of 2 parameters. So we'll explore these in more detail in the subsequent videos, but I just want to go ahead and say right off the bat that our parameterization of surfaces are going to involve 2 parameters, as opposed to our parameterizations of curves, which require just 1 parameter. And so those will look like, if we think of a surface in R3, it will be some function f of uv, g of uv, and h of uv, if we want to think about this as being a function in R3. So in this case, R is a map from R2 to R3. And by the way, folks, this will be one of our early examples of an interesting multivariable function where these higher dimensions are not the same. So folks, next you're going to pick up watching a video by somebody who can do this better than I, Dr. Bassett, and he'll go ahead and go through an explanation of 2D curves and 3D surfaces. So join him in the next video.